Throughout human history, we've looked to the stars with wonder and curiosity, pondering the possibility of life beyond our own planet. Our ancestors stared into the night sky, drawing constellations and crafting stories of celestial beings. The vision of life beyond our world has been a constant companion throughout our journey as a species, from ancient cave paintings to the speculative narratives of modern science fiction. As time marched on, this universal curiosity evolved into a scientific quest. We've harnessed our intelligence and creativity to delve deeper into the cosmos, to unravel its mysteries and seek answers to our most profound questions. Today, our understanding of the universe has grown exponentially. We're living in an era of extraordinary discoveries and technological advancements. We've identified over 4,000 exoplanets, planets orbiting stars outside our solar system. Some of these distant worlds orbit within their star's habitable zone, where conditions might just be right for liquid water and potentially life to exist. We've developed sophisticated tools like the Kepler Space Telescope, peering into the farthest reaches of space, seeking out these potentially habitable worlds. We've sent probes to the outer edges of our solar system and beyond, gathering data and expanding our cosmic horizon. We've even discovered extremophiles, organisms that can survive in the harshest conditions on Earth, from the deepest ocean trenches to the most acidic hot springs. These hardy creatures have forced us to rethink our definitions of habitable, broadening the potential locations where we might find life. Yet, even with these leaps in knowledge and technology, the question remains, are we alone? We've yet to find definitive evidence of extraterrestrial life. We've yet to hear a signal from the stars, a sign that we're part of a cosmic community. Scientists have been searching for signs of extraterrestrial life for decades, using tools like the Kepler Space Telescope to identify potentially habitable planets in distant star systems. These planets, known as exoplanets, orbit stars outside our own solar system and are key in our quest to find life beyond Earth. But what makes a planet habitable? And how do we identify these potentially life-sustaining celestial bodies? The answer lies in a concept known as the habitable zone. This is the region around a star where conditions may be just right for liquid water to exist on the surface of a planet. Not too hot, causing water to evaporate. Not too cold, where it would freeze, but just right. This Goldilocks zone, as it's often referred to, is the sweet spot astronomers look for when identifying potential life-bearing planets. But why is water so important? Well, as far as we know, water is a fundamental requirement for life as we understand it. It's a key ingredient in the biochemical soup that allows life to flourish. So we look for worlds where liquid water could exist, hoping to find a planet that might be teeming with life. But the search for life isn't confined to planets like our own. In fact, life on Earth has shown us that it can adapt to the most extreme environments, expanding the potential habitability of other planets. These hardy organisms, known as extremophiles, can survive in conditions once thought inhospitable for life. From the scalding hydrothermal vents on the ocean floor to the freezing cold of the Arctic, life has found a way to thrive. These extremophiles have changed our perspective on what is necessary for life to exist, expanding the search for life beyond planets like our own. They've shown us that life is resilient, adaptable, and perhaps more common in the universe than we once thought. The search for life, be it microscopic or intelligent, continues to be one of the greatest scientific endeavors. As our technology advances and our knowledge expands, we press on, exploring the cosmos, seeking answers to our most profound questions. These extremophiles have expanded our understanding of where life can thrive. Our own solar system holds tantalizing clues. Mars, once believed to be a barren wasteland, may have harbored liquid water in the past. As we delve into the mysteries of our celestial neighborhood, we uncover intriguing possibilities for life as we know it. The red planet, with its strikingly similar attributes to Earth, has long been a subject of fascination. Scientists believe that billions of years ago, Mars was a wet world with a thick atmosphere. It had rivers, lakes, and even an ocean that covered much of its northern hemisphere. But over time, Mars lost its magnetic field, causing solar winds to strip away its atmosphere and water. Today, it's a frigid desert world with a thin atmosphere, but beneath its rusty surface, evidence of its wetter past still exists. In recent years, missions like NASA's Mars rovers and the European Space Agency's ExoMars have been exploring the planet's surface for signs of past or present life. They found minerals that only form in the presence of water and have even detected traces of methane, a gas that on Earth is primarily produced by living organisms. But perhaps the most compelling evidence comes from the discovery of underground lakes. Using radar data from the Mars Express spacecraft, scientists have identified areas of high reflectivity beneath the planet's south pole, a strong indication of liquid water. These subglacial lakes, if confirmed, could provide a refuge for life. On Earth, similar environments are teeming with microbial life, and even though the conditions on Mars are harsher, life as we know it has shown a remarkable ability to adapt and thrive in extreme environments. The search for life on Mars is far from over. Future missions like NASA's Mars Sample Return aim to bring back Martian rocks and soil to Earth for detailed analysis. These samples could hold the definitive proof of past or present life on Mars. Recent discoveries suggest that liquid water may still exist beneath its surface, and where there's water, there might just be life. Mars continues to intrigue us, its secrets hidden beneath the dusty red soil, a silent testament to the resilience of life in the universe. When searching for alien life, we look for biosignatures, indicators in the atmosphere or on the surface of a planet that could suggest the presence of living organisms. So, what exactly are these so-called biosignatures? Well, they're signs of life, quite literally. These can be anything from chemical imbalances in a planet's atmosphere that might hint at biological activity, to specific patterns or structures on a planet's surface that could indicate the presence of life. Imagine you're a detective and you're trying to solve a case. You're looking for clues, pieces of evidence that can help you solve the mystery. That's essentially what astrobiologists are doing when they're hunting for biosignatures. They're using powerful telescopes to examine distant planets, looking for any sign, any clue that might suggest there's life out there. Now, there are many different types of potential biosignatures. For instance, one of the most promising signs of life on another planet would be the detection of oxygen in its atmosphere. On Earth, oxygen is a byproduct of photosynthesis, a process carried out by plants and some types of bacteria. So if we were to find oxygen in the atmosphere of an exoplanet, it might suggest the presence of similar photosynthetic life forms. But oxygen isn't the only gas that could indicate life. Others, like methane or nitrous oxide, might also be signs of biological activity. In fact, even the presence of certain unusual combinations of elements could be a potential biosignature. For example, on Earth, we see a peculiar combination of oxygen and methane in the atmosphere. Separately, these gases could be produced by non-biological processes, but their coexistence is thought to be a strong indicator of life. That's because, in an atmosphere without life, methane and oxygen would quickly react with each other and disappear. So, as we continue our search for life beyond Earth, we're keeping our eyes peeled for these and other potential biosignatures. It's a daunting task, but one that holds the promise of answering one of humanity's most profound questions. Are we alone in the universe? These biosignatures could include the presence of certain gases like oxygen, methane, or even unusual combinations of elements. But despite our efforts, we've yet to find definitive evidence of extraterrestrial life. This paradox, known as the Fermi paradox, raises profound questions about the nature of the universe and our place within it. The Fermi paradox, named after physicist Enrico Fermi, is the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. With billions of stars in our galaxy alone, many of which likely host planets, it seems statistically likely that intelligent life should exist elsewhere. Yet, the silence from the cosmos is deafening. Several theories have been proposed to explain this paradox. One is the Great Filter Theory, which suggests that at some point in the development of a civilization, there's a significant barrier or challenge that's difficult to overcome. This could be anything from a natural disaster to self-destruction through war or environmental damage. If this is the case, it could mean that many civilizations have risen and fallen without ever making contact with others. Another theory is the zoo hypothesis, which posits that advanced civilizations are aware of us but choose not to interfere, much like zookeepers with animals. Or perhaps the vast distances and the sheer scale of time mean that our signals are yet to reach anyone out there. But as we grapple with these theories and the silence from the stars, we continue to search. The future of our quest for extraterrestrial life is filled with promise. Upcoming missions aim to probe the atmospheres of distant exoplanets for signs of life, and new technologies may allow us to detect more subtle signs of intelligent civilizations. The pursuit of this knowledge drives us forward. Each new discovery, each piece of the puzzle we uncover, brings us one step closer to the answers we seek. The universe may be silent for now, but we continue to listen, to explore, and to question. Every new discovery brings us closer to unlocking the mysteries of the universe and understanding our place in the cosmos.